All right, so number 10 on the team round 2018 math counts. Here we go. How many 5-letter permutations can be made from the letters in the word addition? Now, before we get started, we need to make sure we understand what a permutation is. Now, a permutation is a way of ordering numbers, letters, objects, whatever. But the question is, how many ways can we order them where the meaning matters, depending on the order of the objects? Now, permutation is almost always going to have to deal with numbers and letters, because if I have the letters D, O, and G, what does that spell? Well, that spells dog. So then what happens if I scramble the letters? G, O, D. Do I have the same meaning? Are God and dog the same thing? Well, some people may say yes. Others may say no, but whatever. The meaning has changed. I think you see that. So we do need to understand the equation for permutations. The equation for permutation, permutation being the big P, and we have n for the absolute total number of objects or numbers or letters we have, and then we have the letter R for how many we're going to use. So permutations can be found by finding n factorial divided by n minus r. That's a lowercase r, folks. And that's in parentheses. That's a subtraction, factorial. Now, again, permutations are really going to be dealing with numbers and letters because the order determines meaning. Now, I'm also going to have to talk about combinations. Now, combinations are very similar to permutation. The big difference is the order doesn't matter. So, let's say we have, and so, hold on a second. So combinations are going to be n factorial. You can watch me struggle trying to write on my mouse pad again. Divided by, I wish I had a touch screen. That would make life so much better. N minus r factorial. And then we're going to multiply by another r factorial. Now, in this case, order does not matter. Order does not determine meaning. For example, if I have Harry Potter book, Chamber of Secrets, Sorcerer's Stone, and what's the third one? Prisoner of Azkaban. Does it matter if I have it in the order of Azkaban, Chamber of Secrets, Sorcerer's Stone, or Sorcerer's Stone, Azkaban, Chamber of Secrets? Does the order matter? And the answer is no, because it's the same 3 books. And to deal with taking out the duplicate combinations, that's why we have this extra r factorial in the denominator, because in objects, it doesn't matter what order you have them in, it's just you have those same 3 objects. So we're going to have to talk about both combinations and permutations. Obviously, combinations, you're going to be looking at people and objects far more often than numbers and letters, because in objects, it doesn't matter what the order is, you have what you have. All right, so I have 8 letters in the word addition. And so I'm only using 5 of them. And addition has 2 D's as well as 2 I's. Now, I have 3 different cases. I can have no repeated letters, which means D and I are each used exactly once. I can have D used twice or I used twice. And then I could have D and I both used twice. And these are completely separate situations, so I need to treat them separately and then add up the total number of permutations at the end. So that's my strategy. Let's go. Now, case 1 is the most pure of the permutations. No repeats. So I have 1, 2, 3, 4, 5, 6 letters. So that's going to be my n value. So I have 6 factorial. And then I'm going to divide it by 6 minus 5, because I only need 5 of the 6 letters. 6 minus 5 factorial. And so then we're going to get 6 factorial over 1 factorial. 1 factorial is just 1. And so we get 6 factorial. And 6 factorial, as I'm sure you know, 6 times 5 times 4 times 3 times 2 times 1 is 720. make that look a little more like a 2. And so that's how many permutations we have with no repeats. So then that brings us to the next situation, case 2. And this is probably the more difficult of the two. So we have d's repeated, or we can have i's repeated. Now the number of permutations for the d's repeated is going to equal the number of permutations for the i's repeated. So I'm only going to have to figure out one of the two and then double it. So right away I know that I'm going to have to multiply permutations by 2 to deal with the I repetition. So first things first, let's go ahead and figure out choosing the letters. So if I'm going to be choosing the letters, choosing, that is a combination. So I have D and I have D, and then I have 3 more spots, and of those 3 spots I have 5 letters to go in there. So that is going to be 5 over 3 minus 2, and that's in parentheses, factorial, times 2 factorial, or sorry, my R value is 3, so that's times 3 factorial. That is brutal handwriting on the mouse pad. All right, and again, I'm choosing which numbers or which letters to use. I'm not worried about order yet. I'm just choosing which letters I'm using. And so from that case, I'm going to get 5 factorial over 3 factorial times 2 factorial, because 5 minus 3 is 2. Now, that means we're going to have 5 times 4 times 3 factorial. The reason why I'm going to call that 3 factorial is because I'm going to divide by 3 factorial. And I also have this 2 factorial is just 2 times 1, so that's just 2. And 3 factorial divided by 3 factorial is 1. 4 divided by 2 is 2. So that means 5 times 2 is 10. So there are 10 ways of choosing the total letters. All right. So now, how many different ways can I scramble them? Well, for the scrambling, that is going to be a permutation, because the scrambling the letters is going to define the meaning of them. So I have 5 letters, and 2 of them are repeat. So that's 5 factorial divided by 2 factorial, and that is going to give me 60. 5 times 4 times 3, 5 times 4 is 20, times 3 is 60, and then the 2 gets canceled out by the 2 in the denominator. All right, so now we're looking at 10 times 60, so that is 600 different ways of getting double D's. Well, I have to multiply that by 2 because I could get double I's as well. So 5, sorry. So I have my 2 from the 2 different letters doubled, times the 10 for the different ways of choosing, times the 60 for the different ways of orientating them, or the arrangements, and I will get 600. Or not, I'll get 1,200. Up here I had 720. And so then, moving on, what happens if we have them both doubled? Well, so that means we're going to have D, a D, another D, an I, another I, and some other letter. I don't know what letter that is. And remember, I also have to worry about scrambling them. So how many different letters can go here? And this is going to make life much easier. Well, I can only have 4 different letters going here, right? I have the A, I have the T, O, and the N. So now we have to worry about how we scramble those. And so that's going to be 5 factorial. And I have 2 letters that are repeated. So that's going to be 2 factorial divided by 2 factorial. And so we get, well, we just get half of this, right? I hope. All right, so we get 30. And so, since we have 4 different letter options and 30 ways to scramble things, we get 4 times 30, which is 120. So now we just add those 3 cases up. So we have 720 plus 1,200 plus 120 for a grand total of, I want to use a calculator because, you know, I don't want to mess it up here, right? So I get 720 plus 120. I get 1,329. All right, there we go.